Question number 3. Explain how a linked list structure consists of cells can be used to implement the interface list. An explanation in English is sufficient. Possibly with diagrams, you're not required to write code for implementation to answer this question. So it's saying you can explain in English, you can explain in diagrams, you can have a mixture of the two. So as I said before, diagrams are quite good. A visual diagram quite often explains things, but don't just give the diagram, you do need to explain a little bit in English. You could give a more full explanation in English without diagrams if you want, it's up to you. If you really wanted to write it all in code, you could do so again with explanation, although I think writing all the whole code out would be longer. And actually question A4 is asks you to write code, which will be part of the answer to A3. Okay, so the code will be asked for is question A4. Now let's look at where this is in the notes. We've got notes on linked lists, and it's really asking you to do straight what's explained in section 2 as implementing array list using linked list. It's more or less a straight demonstration of knowledge of all that section 2 in linked list is about. So let's look at it. Okay. Array like operation on a linked list structure. We've got our linked list. Now, the important thing is, and this is where I find a lot of people get it wrong, don't confuse the implementation of the list with the cell object. The cell, linked list cell is inside the implementation. We've got a myArrayList object here, but myArrayList, because in the whole notes we've seen various implementations of ArrayList. Inside that is a linked list, a cell field. They're not the same type, it's two separate classes. This is what I find people quite often get confused, possibly because of old-fashioned textbooks tended to confuse the two. The linked list as the internal structure and the array list as the actual object which implements the list. Two separate things, one is inside the other. Now let's consider, think about this. Suppose we want to represent the list. 10, 20, 30, 40. It could be a list of anything, but let's do it in integers. Now, the linked list representation of that, well, we've seen previously cell object with the first and next field, but we've also, as we've seen in the notes, as a simpler way of writing this to indicate that a cell object consists of two parts, cells and pointers diagram. So this is a cell object again, but in this case the first variable is the left hand side and the next variable is the right hand side. It's shown in a slightly simpler form, and then we put the next value directly in the box. Okay, it would actually be a reference to an integer object, but for simplicity we just push it in the box, and then the arrow next forms our chain of cell objects. Now that's the linked list which represents the array list, but as I said previously, you need to distinguish between this internal representation and the array representation. So we have an array object, and inside it is a reference to a cell, and that gives us the linked list. It's not, we've got to distinguish between the array object and the cell object, and the cells are linked together. Okay, so to answer question A3, all it's really needed is this sort of diagram and some sort of explanation in English of how this represents that. That's it. That's the answer, and it's fairly straightforward, because all this material is in the notes. You really just need to understand what's in the notes and to explain it on this topic. Well, I'm reasonably happy with my answer here. You see I've switched to the square, the block cells and pointers notation. A couple of things I wasn't quite happy with. I found out started with arrays here, and I called it R, which is called, this is not an array. An array is a data structure. What I actually mean is R is a representation of an array list. So it should be a list using the internal representation of linked lists. It's not an array, although an array list operates like an array. So perhaps just to clarify what I meant there, and again, so if I was writing this down and I started using array, when I meant array list and list, it's not quite right. So it's very important to distinguish from the data structure and the abstract data type it's trying to implement, in which in this case is a list. Array list is a list implemented using arrays, and linked list, the Java type linked list, capital L, is actually like an array list implemented using linked list in this form. Don't confuse the linked list data structure with Java's linked list class. It's very easy to do that, and I know a number of people are confused by it, but remember, Java's linked list is a list implemented using the linked list data structure. So it's really, you could say, a linked list might be a better way to call it. So I'm really happy with this, but just to clarify, perhaps at the end I was confused between these different concepts of the data structure and the abstract data, which is a list, and I started saying array, and I really meant list or array list.